Welcome to the Game Audio Resource Wwise and Unreal Audio Implementation Guide series. In this step, we set up Wwise with a blend container using a fake distance game parameter, allowing us to switch close and far audio assets based on the player character or listener position distance from the water source location. First, we set up Wwise with the Waterfall content. We set up a fake game parameter that we can use with the blend tracks we're about to implement. Navigate to the Game Syncs tab, Game Parameters. Right-click the default work unit. Then select New Child, Game Parameter. Name it GP_distance_5000. Select the game parameter. Then change the range values as follows. Min equals 0, max equals 5000, and default equals 5000. Under Bind to Built-in Parameter, change the drop-down list to Distance. Navigate to the Audio tab, Actor Mixer Hierarchy, Default Work Unit, Environment Work Unit. Right-click, then select New Child, Actor Mixer. Name it EMV_Waterfall. In the General Settings tab, Output Bus, change the Master Audio Bus to the Environment Audio Bus. Also, in the General Settings tab, under Game Defined Auxiliary Sends, tick the Use Defined Auxiliary Sends tick box. Right-click the Actor Mixer, then select New Child, Blend Container. Name it EMV_Waterfall_flow. With the blend container selected, in the General Settings tab, click on the Blend Track Edit UI button. In the Blend Track Editor window, click on the New Blend Track UI button. Name the new blend Waterfall Flow Distance. Then close the Blend Track Editor window. Right-click the blend container, then select New Child, Random Container. Copy and paste the random container so that you have two random containers. Then name each random container individually EMV_Waterfall_flow_close. and EMV_Waterfall_flow_far. Then drag in looping close and far waterfall flowing water audio assets. Place them under the file importer destination path, SFX, environment, then waterfall. Select each of the new looping audio assets. Then in the General Settings tab, tick the Loop tick box. With the blend container selected, in the Content Editor, add the close then the far random container to the blend tracks list. Open the blend container. Tick the Crossfade tick box. Then click on the Arrow UI button. Assign the game parameter GP_distance_5000. Then add the following changes to the assets in the graph. Close equals 0 to 3000. Far equals 500 to 5000. Navigate to the Share Sets tab. Right-click the Environment Work Unit. Then select New Child, Attenuation. Name it ATT_EMV_Waterfall_huge. Double-click the attenuation to open the properties. Then add the following changes. Change the max distance value to 5000. In the graph, add a new point marker at the following coordinates, x equals 500 and y equals 0. Right-click the red line after the 500 point marker, then select Logarithmic Base 3 Curve. Then select the low-pass filter in the list. Change the drop-down menu to Custom. In the graph, drag the endpoint to 50. Right-click the blue line, then select Logarithmic Curve. Select the Spread List entry, then change the drop-down menu to Custom. In the graph, add a point marker at x equals 250 and y equals 100. Then add a second point marker at x equals 750 and y equals 8. Right-click the line between the 250 and 750 point markers. Then select the sign Constant Power Fade-In Curve. Right-click the line after the 750 point marker, then select the sign Constant Power Fade-In Curve. Select the Focus List entry, then change the drop-down menu to Custom. In the graph, add a point marker at x equals 250 and y equals 100. Then add a second marker point at x equals 750 and y equals 8. Right-click the line between the 250 and 750 point markers. Then select the Sine Constant Power Fade-In curve. Right-click the line after the 750 point marker. Then select the Sine Constant Power Fade-In curve. Navigate back to the Audio tab, env_waterfall_flow blend container. In the Positionings tab, add the following updates. Tick Override Parent, then change the center percentage to 100. Under Listener Relative Routing 3D Spatialization, in the drop-down menu select Position. Then under Attenuation, drag in the new attenuation, env_waterfall_huge. Right-click the blend container, then select New Event, then Play. Right-click the blend container again, then select New Event, Stop, then Stop. Navigate to the Events tab. Right-click the Event Work Unit, then select New Child, Virtual Folder. Name it env_waterfall. Drag the two new waterfall events into the new virtual folder. Then rename the events to sfx_env_waterfall_flow_start and sfx_env_waterfall_flow_stop. Select each of the two events individually, then add a fade time value of 0.5. Save the Wwise project updates, then generate the Wwise sound banks. At this point, we recommend you also add two further waterfall audio content, sfx_env_waterfall_top and sfx_env_waterfall_bottom. These two different emitters will not need to use blend containers, but will have smaller attenuations. We place one emitter at the top and the bottom of the waterfall, allowing for realistic waterfall details depending on how close the player character is to the waterfall position. Next, we set up the Unreal data with the new Wwise waterfall content. Navigate to the Content Browser, Content, Audio, Wwise_Events, sfx_environment folder. Right-click, then select New Folder. Name it env_waterfall. Open the Wwise Picker. Then drag in the new waterfall events into the new folder. Select all the events, then right-click and select Edit. Assign all events to the sb_environment soundbank. Save the event updates. Generate the Unreal soundbanks. Then import the updated soundbank content. In this step, we duplicate the spark particle effect, then remove the spark detail. In Unreal, navigate to the Content Browser, Content, Starter Content, Particles folder. Copy and paste the particle called p_sparks. Rename it to p_waterfall. Double-click the new particle effect. Then in the new window, under the Emitters tab, click on the Spark Burst tick box to turn off the spark effect. Then save the particle update. First, we need to build a rock formation for the waterfall to flow down. Then tag into the map the new p_waterfall particle to form the waterfall. Then place the SFX events onto the waterfall position. In the Content Browser, Content, then Starter Content, Props folder, drag in two SM_rock models to the map. Then enlarge the rocks to a large size. Drag the two rocks together. The joining part of the two rocks will need to form a natural angle where we can add the waterfall flow particle effect to. Once you have a natural angle, we can now add the p_waterfall particle to the rock formation. Navigate to the Content Browser, Content, Starter Content, Particles folder. Drag in the p_waterfall particle into the map. Place it at the top of the waterfall position. The particle effect looks quite underwhelming, so we'll need to increase the size. Select the particle emitter. Then in the Details tab, change the size to the following values: x equals 10, y equals 10, and z equals 10. The particle effect should now look more like a waterfall point. Now copy and paste the same particle effect, to build the height of the full waterfall. Once you have implemented and are happy with how the waterfall looks, in the World Outliner tab, right-click the Structures_Boxes folder. Then select Create Subfolder. Name it Waterfall. Now we can add the SFX emitters. First we add the main waterfall layer. Drag in the event called SFX_EMV_waterfall_flow_start. Place it in the middle of the waterfall height. Then drag in the two other waterfall top and bottom events. Place them individually at the top and then the bottom of the waterfall. Remember to tick the Auto Post tick box. And turn off the occlusion by setting the value at 0.0 for each new SFX emitter added. In the World Outliner tab, right-click the Audio_SFX folder, then select Create Subfolder. Name it EMV_waterfall. Now save the map updates. We can now test the updates in-game. Connect Wwise to Unreal. Solo the Waterfall Actor Mixer. Then change the Wwise Layout Profiler. Filter the capture log by the waterfall content. Then play the map. Move the player character close and far away from the waterfall location. If you have the blend values cross-fading smoothly, you will not notice the close and far distant audio assets changing over distance from source. You also notice the bottom and top emitters detail also shines as you get closer to the emitters. Make any Wwise balancing changes you wish to make, then disconnect Wwise to Unreal. Save the Wwise project updates, then generate the Wwise sound banks. Lastly, generate the Unreal sound banks, and import any new sound bank updates.